of this level of math is just knowing the different types of basic functions. And there's a lot of them out there. And so we want to be able to know and understand the sine and cosine functions. These are our primary two functions. We will also learn the tangent function. And then we'll learn all the reciprocal functions. Okay? We will spend an entire week just on sine and cosine. Because if you can learn how to graph sine and cosine, all the rest come from those. And so we're going to spend a lot of time just figuring out how to graph sine and cosine. And of course, you do have a calculator. And we will learn to use the calculator and use it to verify our graphs. But I do want you to be able to graph these by hand. Okay? So we are starting with what we know of the unit circle. So example 1, we're going to graph our basic function y equals the sine of x. We're going to graph this for x values between 0 and 2 pi. So x is our angle measure, our angle of rotation, which would just represent one rotation of our unit circle. We'll talk about the domain and range and the period of our sine. Sine and cosine curves are really cool, and they happen naturally all over. So we will be doing another project where you'll actually be finding the equations of sine and cosine curves, from weather temperature, which will be kind of fun and really interesting. All right. So you can see over here, I've drawn basically a unit circle. And we want to start, our x represents our rotation to go from 0 to 2 pi. So we're starting here where x is 0. So I'm going to mark 0 on my graph on the x-axis. And we're going to go all the way around one rotation of our circle, and we would wind up at 2 pi. So I want to conclude here. I'm going to just make a mark down here, 2 pi. Give yourself a goodly amount of space. Now, if I didn't go all the way around the circle, I'd stop here. Maybe I'd just go halfway. Where did I stop if I went halfway? At pi, yeah, sure. So I'm going to mark pi also right in the middle of 0 and 2 pi. And then if I didn't go to pi, but I only went halfway, I would stop right here. And what's right here? Pi over 2, right? Okay, so halfway between 0 and pi is pi over 2. What's halfway between pi and 2 pi? 3 pi over 2, yeah. 1 pi over 2, 2 pi over 2, 3 pi over 2. Halfway between pi and 2 pi is 3 pi over 2. Which I just would like to point out. What's 1 pi plus 2 pi? 3 pi and then cut in half. 3 pi over 2. All right, okay. We're going to talk more about that. All right. What I've done here is I have created 1, 2, 3, 4, 5. 5 key points along my horizontal axis. Okay. Those are the 5 key points you need to have every time you graph. All right, we're going to talk about how to get those. It turns out it's pretty easy. It's a little bit of fraction work, but by and large, it's quite easy. And then we want to talk about the actual sine values as we rotate around our circle. So if we were to start right here at 0, what's the ordered pair at 0? 1, 0. What is the sine value then at 0 radians? 0, sure. So there's a point there, right there, 0. Because, let me do it this way. If you have an x value and we want sine according to x equals our output. So we said at 0 radians, the sine at 0 radians equaled 0. So we have 0, 0 for our ordered pair. So now we go to pi over 2. Pi over 2 is what ordered pair? 0, 1, sure. So at pi over 2, what is the sine of our angle pi over 2? 1. Right there. There's our sine value at 1. So I want to go up to 1 here. At pi over 2, we have an output of 1. Then we want to know next what happens at pi. What's our ordered pair at pi? Negative 1, 0. So what is the sine value at pi radians? Back to 0. Sure, right there, the y coordinate 0. Then we go to 3 pi over 2. 3 pi over 2 is what ordered pair? 0, negative 1. And so what is the sine value at 3 pi over 2? Negative 1. So at 3 pi over 2, we're going to go down to negative 1, our low point. And then completing one rotation of our unit circle, we go back to 2 pi. And so we want to know what is the sine at 2 pi. Back to 0 again. You can see, so if we connect this with a nice smooth curve, nice and smooth, it's not V's, it's just a nice, smooth, rounded curve. I'm a little bit straight in here, but it does, yeah. You'll get good. It's not V's. It's nice and smooth and rounded. Okay. So this is the sine graph. And for sine, we have a sine song. It's a really complicated song. It goes middle, high, middle, low, middle. Okay, your turn. Ready? What's the sine song? Middle, high, middle, low, middle. You see that? My voice goes up because it's higher. Okay? All right. The sine song, middle, high, middle, low, middle, is really important. We're going to sing the sine song all the time. Okay? And it's going to help you remember how to plot those points. Okay? So what's the sine song? Middle, high, middle, low, middle. Yeah, and I really like it when we all sing together because it's really adorable. Okay. Let me ask you a question. We just did one rotation of our circle. But could we keep going around? Yeah, we could go around forever, right? What do you think happens if we continued on our journey? So we were at 4 pi's over 2. We do 5 pi over 2. What happens? It goes up and then middle and then low and then middle, yeah? So we keep doing middle, high, middle, low, middle, high, middle, low, middle, okay? So because it just repeats itself, we are interested in one period. This represents one period. From 0 to 2 pi, the period is a length of 2 pi radians. A period is, hey, after this point, that graph is just going to start repeating itself. All right? And so this represents one cycle or one rotation. And after that, it's just repetition. Okay? And so this regular sine function, this is our basic sine function, has a period of 2 pi. What's its domain? How far left and how far right does this graph go? Does it stop here? Is this all we've got? No, the reality is it goes forever, right? Because it just continue going backwards here and continue this way. So our domain is from negative infinity to positive infinity because it really does keep going. We're just always going to graph the easiest cycle, the easiest period. What's the range of this graph? -1 to +1. How low does it go? -1. How high does it go? +1. And that's really, really important. These domain and range issues are going to become very important when we get to inverse functions. Okay. All right, what's the sine song? Okay, good. All right, I know, I'm a goof. That's okay. All right, any questions on that? Okay, that's the sine song. So now we do cosine. So this is our y equals cosine of x graph. Same thing, all of this comes from our unit circle. And again, we're doing one rotation of our circle. So our angle is measuring from 0 to 2 pi radians. So again, we're starting at 0 radians and we're going to go all the way around one rotation of our unit circle from 0 to 2 pi. So again, I want to start at 0 and way down here, I'm going to end at 2 pi. It's important you understand that this is in radians. And so we can graph these on our calculators, which we will do in just a minute. But what mode should you be in? Radian mode. Yeah. Okay. What is halfway between 0 and 2 pi? 1 pi, sure. 1 pi, which also is right here on our unit circle. What's halfway between 0 and pi? Pi over 2. You are responsible for making all of these markings every single time. What's halfway between pi and 2 pi? 3 pi's divided into 2 parts. 1 pi plus 2 pi is 3 pi divided by 2, okay? Which is right here on our unit circle, 3 pi over 2. And of course, we know all of these ordered pairs, just like we did at 0. What is our ordered pair? 1, 0. So if I wanted to create my little x and y chart here, we're plugging in values for x to get our output value. What is the cosine value at 0? 1. Yeah, the cosine value is that first coordinate there. So we have the point 0, 1. Oh, where does cosine begin? Pi. Yeah. What do you think is going to come next? Middle. Yeah. So then we go to pi over 2. What is the cosine value at pi over 2? So here's pi over 2. What's the cosine value? 0. Yeah. So at pi over 2, we're at 0. Then I want to go to pi. What is the cosine value at pi radians? -1. So at pi, we go to -1. Then we go to 3 pi over 2. What's the cosine value at 3 pi over 2? 0 again. Back to 0. And then at 2 pi, what does it return to? 1. So you can imagine so ladies and gentlemen, what do you think the cosine song is? Hi. middle, low, middle, high. That's it. Okay, so here we go, ladies and gentlemen. What is the cosine song? Oh, come on. High, middle, low, middle, high. Okay, that's better. Good, good, good. High, middle, low, middle, high. Okay. Really, really important. You want to keep those things straight. I promise it makes a world of difference. What is the period for this function? Where does it start and where does it end one cycle? Starts at 0, ends at 2 pi. And the length would be 2 pi minus 0, which is just 2 pi. So the standard period for the sine and cosine parent function, the period is length 2 pi. Eventually we're going to be shortening and expanding that, but for starters it's 2 pi. What's the domain? All real numbers, negative infinity to positive infinity. Again, this continues on in the same cyclical, that is the word, cycle, that cycles over and over again, cyclical. In the same cyclical pattern over and over. What's the range? Negative 1 to 1. Very good. Our lowest value is negative 1 and our highest value is 1. Okay. I want you to graph this on your calculator. So the first thing you want to do is, there we go. First thing you want to do is make sure that you're in radian mode. So I'm going to go to mode and make sure I'm in radians. And then we're going to go to our graphing menu, y equals. We have a cosine and then x. And I highly, highly, highly recommend doing the zoom trig menu. So if you go to zoom, and then you have Z trig. That's the trig graphing window. It's a very good window. And so that's a great window for graphing that. I'll have to look for the Casio. I haven't done it in a while, so I've got to remember if we've got a Casio. All right, so what are we seeing here? 0 is the high value, and it looks like we've got 0, 1, 2, 3. It looks like it's almost the same, like from 0, 1, 2, 3, 4. 4 little extra points there, including and 0. So our window is just going from 0 to 2 pi. That's what we did graphically. This window on the calculator goes from negative 2 pi to positive 2 pi. And again, they're counting just like we are with pi over 2 as our little tick marks on our axis. Okay, and you can see all that if you go to window. It's going from just about negative 2 pi, should be negative 6.28, to positive 6.28. It's very close. Okay. All right. So we can do some graphing. It's kind of interesting, but we'll do some more of that. Today, we're graphing sine and cosine. And today, we are going to have changes in A and changes with the D. Okay. The stuff that's inside with X, we'll deal with in a couple of days. Actually, starting tomorrow. And that's going to change things in the X direction. The A and the D do something else, and we want to see what happens there. So in your calculator, we're going to start. I want you to graph y equals sine of X in y1. And then we want to do 3 sine of X minus 2 in y2. So in y1, we're going to put sine of X. And then in y2, we're going to do 3 times the sine of X. And then subtract 2. You'll notice that the parentheses are just around the X and not the X minus 2. Very important. What do you think is going to happen? What do you think that minus 2 is going to do to the graph? It's going to shift it down. What do you think the 3 is going to do? Stretch it Vertically, yes. Both of these are vertical changes. This is multiplying the sine function, making it taller by a factor of 3. And the D on the outside shifts it up and down. So that's really good. So here's our regular sine curve. Look, middle, high, middle, low, middle, Okay. Oh, there's our shifted function. It's much lower. You can see that it got shifted down too, right there. Okay. And it's much taller. All right. So what does the -2? How does the -2 change the graph? Shifts it down 2 units. How does the 3 change the sine graph? What did that do? To go from our starting point here, and then it's 3 times as tall. 3 times the tall. What's the range, do you think, of this function? How high does it go and how low does it go? It goes all the way up here to 1. How low does it go? I'm going to change my window. I want to go a little lower here. Let's go to -6. My y minimum, I'm changing to -6, and I'm going to see what happens. Ooh. So -5, yeah, the low, it's going from this range is going from -5 all the way up to 1. How far is that? 6 units. 6 units, that's interesting. What's the range of our regular function? -1 to 1. How far is that distance? 2 units, right? From -1 to +1 is 2 units. Oh, so what happened to our range? It's 3. Yeah, this was 2 units. It's 3 times bigger. Interesting. Okay. So this is a stretch vertically of 3 units. Stretch by a factor of 3, really. We're multiplying it by 3. All right, you don't have to write all of this stuff, but what I would say is important is what I call the D. The D I refer to as the vertical shift, or what I like to call the midline. All right. When we're graphing, I'm usually going to start by just drawing in the midline. Using a dotted line, we're not usually graphing on the x-axis, so I'm just going to use it as reference. Midline as in middle, when we sing our sine or cosine song. Okay, middle high, middle low, middle meaning midline. So I use the word midline a lot to represent that outside D value. A is the amplitude, sort of. Amplitude is the distance between the midline and the highest point. So here, we would say our amplitude was 3. Amplitude is always positive. We'll talk more about that. And it's the distance between the middle and the high, or the middle and the low. Okay. So we go 3 above the midline or 3 below the midline in this case. All right, let's graph a couple, and then I think you'll probably be fine. So amplitude, we can also make negative. If our A value is negative, then our graph is going to do what? Flip. It's a vertical reflection. It flips upside down, so it's going to change our song. All right. All right. We're going to graph each function. You don't have to write all these directions, but example 3 is graph. Graph the function. Every time you graph, you're going to have 5 key points for 1 period. I want them so clear there is no question what it is. We're going to find the amplitude and the midline, domain, and range of each function. And then graph verify using your calculator. Absolutely, I will never put keys out for graphing because you want to be able to do it on your calculator, okay? All right, so we have our regular sine function here. We have a 2 out in front. What's the number on the end? 0. So our midline is 0, and our amplitude, in this case, is the number in front. That's the 2. So what I'm going to do is I'm going to draw my, in this case, just the x-axis, where we're at 0. And if the amplitude is 2, this is our midline here at 0. What's our highest value going to be? 2. What's our lowest value going to be? -2. Yes, good. Once I have my midline and my amplitude, that gives me all the information I need in the vertical direction, okay? We want to, we have a standard sine graph which starts at 0 and ends at 2 pi. What's halfway between 0 and 2 pi? 1 pi. What's halfway between 0 and pi? Pi over 2. And what's halfway between pi and 2 pi? 3 pi over 2. Every single time, I want you to graph the first 0 and the 2 pi, the beginning and the end, then the middle, then the middle, then the middle again, okay? And when you do it that way, your graphs will always be very, very good. These are the 5 key points that all now I have to do is sing my sine song. What is the sine song? Middle, high, middle, low, middle. So on my first point here at 0, we are going to graph middle of the line. Middle, midline, middle, high, middle, low, middle. And you have just graphed a perfect, sine curve. One period. Do it that way, it'll look perfect every single time. I can also easily tell what points you actually are graphing. What is the domain of this curve? Negative infinity to positive infinity. What is the range of this curve? -2 to +2. 4 units in length. Okay. Cool. Let's look at letter B. What's the D value? What's the number on the outside? 0, yeah. So our midline is 0. And what's our amplitude? Trick question. Amplitude is always positive. And the reason it's always positive because the definition of amplitude was the distance between the midline and the highest value. Distances are always positive, okay? And so anytime we talk about amplitude, if I'm asking what is the amplitude, it is always going to result in a positive value. But what does the negative do to our cosine function? It flips it upside down. So this is a reflection vertically, which is going to change our cosine song. What was the original cosine song? High, middle, low, middle, high. But this one is negative. It's been flipped upside down. So it changes that song. What is the song now? Low, middle, high, middle, low. Does that make sense to you? Okay, it's literally flipped upside down. So let's see, I'm going to graph my midline, which is occurring at 0 in the y direction. And then what's my highest value going to be? 9. What's my lowest value going to be?